just okay. Morning all. So as you guys join, yesterday you were supposed to get two documents from a lecturer. So if you have received it but haven't looked yet, um, just check. But please share it with me as well. In the document is supposed to be. Let me just read what the lecturer told us is about the mock exam, how the um, invitation works, how the exam site works, how all of those things work. Um, so please send that to me. You can send it email or WhatsApp. It doesn't really matter. So let's gonna. I don't know if anybody, if the chat box is also recording. So please send it to the email that I am typing in now. So you can just send it to my Gmail account. That is it. So I don't know that. So please send it when I'll just go through it as well, and then we can answer some of the questions that has been raised on the forum as well. But what's supposed to be in it and what the lecturer said, so they are forced to use now one of those, I don't even know how to pronounce it, invigilation or something like that tools, but it is supposed to be already built into the new MyUnisa Moodle exam page so that you don't need to download anything else. Um, and that also then gives you the opportunity to actually use not just your not just a laptop but any other device as well. Um, it is supposed to be open book, but I want to see out of those documents if that is confirmed or not. And if there's nothing in there saying about it, I will just make 100% sure about it. Okay, so let's yes, Lynn, you can quickly.
No, I just said, okay, cool. Thanks, John.
Cool. Okay, so let's go on. It is a long session today, so we might. I have my 2 cups of coffee in front of me, so we might just take a leg stretch somewhere in between. Um, and like we're going to do the first question, it was posted on the WhatsApp group. So please, if there's other questions, I know you also individually WhatsApping me. Um, I need to get to some of those questions still. But also please put questions on the WhatsApp group that we have, and I will try to incorporate it into our sessions, because if one person is struggling with it, there's probably more that is struggling with it. Um, so let's look at what they've given you in this one. So they've given you a bit of information, but not all. Um, so they've given you the cumulative frequency. So remember, cumulative frequency is every time when we add up the previous frequency. So your first cumulative frequency will always be the same as your frequency. So that will always start at 2. Then 2 plus 3 give you the next one, 5. 5 plus 7 give you 12. Now we see, look, we're in here between a few different things. So let's see if we can sort out the rest. 17 plus something must give me 20. Okay, so let's work that out then. So 20 minus 17 give me 3. So 17 plus 3 will give me 20. So the only one that is really left out is this one. We know there's in total 20. That's the maximum that we have in here. So all your frequencies needs to add to 20. So to get that one, we just need to add all of the numbers, subtract it from 20, and we will get what is that open one. So 10, 12, 16, 19. So it seems like 1, and we can test it. 12 plus 1 must give me 13. 13 plus 4 give me 17. Okay, so we've done the table now. So now it is to look at the questions. The frequency of class 22 to 28 is 3. 22 to 28 is 3. So that one is incorrect. What are they asking? Okay, incorrect. So that one is then the one that is wrong. Let's just look at the other one. The modal class is between 16 and 22. Modal, the class that happens the most, 2, 3, 7, 1, 4, 3. So 7 is definitely the most. So the modal class is correct. Number of observations that we saw, 20, correct. 13 computers were sold for less than 28,000. So if we look at that, so your cumulative frequency tells us how many up until that point. So less than that is basically then 13. Okay, so 13 computers were sold for less than 28,000. And then the relative frequency of class 3, 4 to. Okay, so now they're asking us, and this, why does that also look wrong? 34 to that, so 3 divided by 20. Sure, what does that give us? 0.15. That also looks wrong. Ah, it actually gives us that. So 3 divided by, so that is also correct. Okay, so the one that was wrong in this instance was the first one, but you need to, like I showed now, you need to nearly complete the table before you do that. Else you could have said 7 minus 4 to get a 3, or you could have done something else to get that 3. You could have said 20 minus 17 to maybe get a 3. There might have been ways that you could have maybe got to a 3, but it's definitely not that. Okay, so this was from the chat. So please, if you get more like these, put it on the chat, and I will include it in one of our sessions. Okay, so let's continue where we then left off last week on probabilities. So last week we did the normal probabilities that included mutually exclusive, um, independence. You got your cross tabs. You needed to say given something. Now we're going into study unit 5, where it's about discrete binomial Poisson. Um, so once again for this we have some kind of, and let me just see where it is, some kind of possible help in a sense of the Excel spreadsheet. Um, again, does not always work, or always assist in certain things. Um, so let me, it could have even been, okay, so we don't, it's not exactly right for what we've done here. So we will change the values and then we will see those two answers. Okay, so first I'm gonna not show that. Um, probabilities we need to work out. So the probabilities we need to work out from a table. There's no easy way else to work that out. So let's look what they tell us. They give us this probability table. This time everything is included. They haven't left out probability that we need to fill. That can still happen as well. In another question, which of the following statements is correct? Okay, so again, correct. We seldom get into questions. So for me, just be read your read your question in the exam nearly 2 or 3 times before you answer it. Just because of seldom get that they ask which one is correct. So just make sure that you do it, because if I read that, I read it as incorrect, probably I would have said the first one is incorrect. Probably your last answer is the correct one. Um, but now when your answer is shuffled, it can be something different. Okay, probability of X. So we know in this distribution um, that we're getting the same in when we get to Poisson. um, I'll show you that later. Binomial, all of the distributions add up to 1. Okay, so the sum of the probabilities that is not equal to 1, that's definitely incorrect. It will always add to 1. Okay, then let's look at probability of X smaller than 1. So does not include 1, smaller than 1. Okay, so that probability is actually 0.05. If I give that, so it's incorrect. Probability smaller and equal to 3. How I normally like to do it, smaller and equal to 3, so it includes 3, bigger equal to 1. It includes 1. So you're looking at what they're asking, smaller or equal to 3, bigger or equal to 1. So they're including all 3 of that. So that is 0.4. So we're actually looking at 0.6, which in this instance is also wrong. Okay, here they were nearly going for that 0.2. So to get that 0.2, this is how the formula would have looked like. Just that you have a view of that. Okay, that would have been equal to 0.2 because you would have said x is smaller than 3, so then it doesn't include 3. X is bigger than 1, it doesn't include 1. Then it would have been, and I'm doing something like this, would have been that. Okay, so if I have taken away the two equal signs, that is how you would have gotten to that equal to 0, 2. Okay, so the next one is these two and how to work out the mean value. So let's do it. I'm gonna just show it here. So how to work out the mean value is we need to calculate, and I think the sum is something like, or the formula is something like this. So we need to say the x times the probability, and then we need to add all of them. So for this one, it's still quick and easy. 0 times 0, 0.05 is going to be 0. 1 times 0, 0.15 is going to be 0.15. 2 times 0, 0.2 will be 0.4. 3 times 0.25, I think it's 0.75. 4 times that is going to be, 2 times that is 0.7, something like 1.4. Okay, and we need to add all of that together. Ugh, so that plus that is 1, 2, so I'm now getting, oh wait, that plus that is 0.9, 0.9 plus that is 1.3, plus that is 2.7. Okay, so we could have done it by adding all of the things together, and that would have been, the right answer is 2.7. Okay, so let's just put those numbers in a spreadsheet. So 0 is equal to 0.05. 1 is 0.15. 2 is 0.2. Just now make it bigger. 3 is 0.25. 4 is 0.25. Okay, that is 0. But remember, then let's just make sure that that is also out. That sum should not happen, it is wrong. Okay, so you can see this one was from a previous exercise that you could just play around with it to also see the right answer. But there you have the mean, and if I ask the variance or the standard deviation, it is also already included for you. Just make 100% sure that these was the 4 numbers. So if there's anything else in this, then just delete the numbers. Because if I add now a 5th one, it should not even equal, so let's take that away. That all adds to 1, so there's still that thing in there to make sure that all your probabilities adds to 1. For this set, we got 2.8, but once again, nice, also the variance and the standard deviation. All very quickly in Excel, so again, just send me those 2 letters that you received yesterday so that I can see. I assume it should be open book, but let me just see. And if you sent me the 2 letters that you received yesterday, I can just make sure with the lecturer that is the understanding. Okay, so this is just a way of showing it again in Excel, but again you can do it the other way around as well. Okay, so I would have thought now the next one is looking at the same and working out variance and standard deviation, but it's not. Okay, so what I've included for you, I mean, I think this is very nice because that is sometimes one struggles with all these wordings. And again, it is when you in the exam, you sit with a question because let's be honest, this they could have written in a better term. So I would nearly see if I can write this in the mathematical terms for you as we go along as well. Okay, but again, they give you probabilities and then they ask you a set of questions. The first one, what's the probability, call it X, that 2 learners are absent on a given day? Okay, so that exactly 2 learners are absent. We need to look for the incorrect one. So 2 learners absent is only 2 learners, 0.2. Okay, we're looking for the incorrect one that is correct. So once again, sometimes in the exam you see, I got it, I got the correct one, mark it and off to the next one, but they're looking for the incorrect one. So let's look at the probability that between 2 and 5 learners. So let's just first say, I just want to see how it was written there, that we, because you can do it the other way around as well. Okay. Probability that between 2 and 5 learners are absent on a given day. Assume 2 and 5 are both not inclusive. So by that, it means that they are not included. Not inclusive, not included. So we're looking at not 5, we're looking at 4, we're looking at 3, we're not looking at 2. So we're only looking at those 2 numbers, which is equal to 0.45, which is correct. Okay, so they give us the wording not inclusive. I don't even know if not inclusive is inclusive, exclusive. So that also could have said exclusive just because as we go along, I will also do that. Okay, so basically not including 5, not including 2, So we're only sitting with 3 and 4. The probability that at most 2 learners, so I'm writing the X, I'm writing the 2 at most. Let's look at what is at most. At most, no more than. Smaller or equal to 2. Okay, so at most can't be 3, but it's fine to have 2. So it basically tells us what's the probability that there is 2 or less learners in class, 2 or less, 0 0.2, 0 0.2, 0 0.1, add all of that together, 0 0.5. And it's still correct. The probability that at least 2. Okay, so let's that. Let's go to at least, at least, at least, at least. Greater than or equal to. At least 2. Okay, different color, that we just at least 2. So bigger or equal to 2. Okay, so it is 0 0.2, 0 0.3 is already 0 0.5, 0 0.65, 0 0.7. Incorrect one. Bongi, I'm also recording, so I will definitely, after the session, it will be posted again. I know with all the load shedding, a couple of days, networks are really struggling with connections and things like that. So don't worry too much. I'll definitely, as the session is finished, I will post the link and everything to the YouTube channel that you can have access to it as well. I know the networks are really bad at the moment. Then let's look at the third one. Um, so the third one, the probability that between 2 and 5. So let's just write it down again. Between 2 and 5. Let's just see what else are absent. Assume the 2 are both inclusive. Okay, inclusive means that we need to have both of them included. Let's go to another color. Blue. So from 5, including 5, to 2, including 2. 5 to 2. And equal to 0 0.7. So look at option D and option E. Look at what we highlighted, the pink and the blue. Exactly the same. What they're asking us, 2 different ways of formulating that question. And it giving us the same answers. So don't worry in the exam if you for one probability get an answer and for the next one you get the same one and you're like, no, but this, how can this be? Look at that phrasing. So exactly the same answer, if we look at the area that was covered, exactly the same area that was covered, way two different types of questions. One is asking for two that is inclusive, and the other one is just greater than. Um, so yeah, so I think just be careful for those ones that you don't like think here is something weird happening. Just want to do that. So when you guys get this, and I will today after the session um, post this also. And I will also during the weekend, I've got a long list of people requesting all the PDFs. So I'm putting that email together. So I will send you all the PDFs that was created that you have at hand as well with this one. Um, and then also you have this one for what we are going to cover still before your write exam. Okay, but I think this is a nice table as well to have because my first language is not English. So when they start using these things of inclusive, exclusive, not inclusive, greater than and equal to, and all those kind of things, sometimes really difficult to actually know what they're asking. So that is why I included it just for assistance. Okay, let's go to the next one. Okay, so this was one that they asked us to calculate the expected value. Okay, so expected value is where we say the sum of x I times the probability. We'll do it now on the spreadsheet as well. I think this was the question that was there. So that times that is 0. That times that is 0.2. That times that is 0.4. That times that is 0.9. That times that is 0.6. That times that, ooh, I think it's that. Okay, so we need to add all of that together. 0, 0.2, 0.4, so that's 0.6, 1.5, 1.5, 2.1, 2.35. Okay, so that would have been my answer. Okay, but let's, yes, Lynn.
Thanks, John. Just to quickly confirm, is the expected value the same as the mean in this scenario?
Yes,
It is, okay.
precisely the same.
Okay.
Precisely the same. So they can ask you calculate the mean value of the number as well. So again, one of the things that they use interchangeably is or expected value, or they ask you to work out the mean.
Okay, perfect. Thank you.
Also remember something that they sometimes don't use, but they can use as well is to ask you what's the average. I seldom use that word, but it is possible. Okay, so let's complete just 0 was 0.1, 1 was 0.2, 2 was 0.2, 3 was 0.3, 4 was 0.15, there was a 5, 0, 0, 5. Okay, you can see it add up to 1, so that is fine. There is your mean or your expected value, and if they ask variance or standard deviation also calculated for you. Okay, so again, just for something like expected value, sometimes this for me is also fine to work it out just like this, but you don't need to go to Excel or your calculator. But now if the next question was work out the variance or the standard deviation, then it becomes a long question. So let's see if it was actually me. Okay, calculate the variance of the options. We'll just check if it is correct. It was the same numbers. Just want to add this here so you can see that there's the both. And I will share this spreadsheet again as we move along through the options and things like that, so that you have the updated spreadsheet of all our workings. Um, so if you check now this, if I needed to work out this in the exam, then I first needed to get that number back again. So I needed to get the mean. That was 2.35. So again, if you're not using Excel and you get a question like this, even in some of the others where there might be a follow on, write that down so that you don't now come to the next question and then it's like, oh, now I don't have the mean. Now I first again need to work out the mean as well. So that is just for me another reason why I'm using Excel. But if you now needed to work out the variance, you needed to say that, and now I need to get it right. For each one, 0 minus 2.35 square root times 0.1 plus, would have done now the same with that, 1 minus 2.35 square root times 0.2. Okay, and you need to do it for that. Okay. What we've done in Excel for you is we've built in that function already. So let's just check still 0.1, 0.2, 0.2, 0.3, 0.15, 0.5. Okay, so it actually does that calculation for you. It takes that, and let's just do that. It takes the 0, it subtracts the mean that we have calculated, and it does multiply it by itself. And in the next one, we will multiply it by the 0.1. So that step, what we've done in Excel with it is that is in the one cell, and that would have been in the second. So there's your calculation in a one cell, and there's the second one just to multiply it by We could have included all of it into one, but it just makes it very confusing. So calculate the variance. Variance was calculated, but why is it different? Let me just check here. Finally, calculate the variance of a number. It's the same numbers. Let's just check 0.1, 0.2, 0.2, 0.3. Okay, so that was calculated correctly. Just make sure that all of these calculations is correct. Here is the mistake. And let's just check the rest of it. That right. So that was okay. So let's just do it right. Cool. Now it would be fine for you when you need to change it because that is 0, so don't worry too much about that because you see when we add it up it is 0. So there was an error in that. The variance equal to 1.8275. Round it off, and again learn like we said last time. You can see I like the 4 decimals, um, but you go with what is in the answer set. Um, so 1,83, 1,83 is option C. So I don't know why I like the 4 decimals, but yeah, it is one of those that just whatever the answer is, go back to nearly the set of answers and work with those amount of decimals. Okay, so again, I'll share the Excel with you guys so that it is just in certain instances a bit simpler to use the Excel than go through this whole process because it takes time. That is just unfortunate with this and for online environment. It just takes time to work out your calculations. Okay, next one. Let's see if there's another one like this. So this I've seen, and I think it was in your. If it wasn't in your assignments, it was definitely in last year's assignment. Um, that, and you will remember I said, don't worry about formulas, but here they throw in the formula. Um, so let's look at what we are looking at here. So they don't tell us if we're working with a discrete, binomial, or Poisson. Okay, so they don't tell us. Or let's rephrase it, they don't tell us directly. South African Embassy in Sydney knows that voter turnout is 91% of the station. In a random sample, 20 voters, what is the probability that at most 13 will turn out. Hint, the 20 voters in independent trials can either turn out or not turn out. Okay, so they've given you a hint.
Sorry, Jane, sorry to interrupt.
Yes, no problem.
About the last one, last question, I
Yes.
was trying to use my calculator here. Yeah, about this one. I think I got 17 point something. I was using a manual one. This formula that you're applying here.
See, and
I don't know
the
where did I get it from.
see, and the problem with it when you use the calculator, let's quickly check. So you got 17.635 or something like that.
Yes, 17.635.
Okay. So what you did is you actually, before you multiplied it with still the probability, you added that component. So let me show you what you did. You said 0 minus 2.35. You did
Yes,
that. Then you said plus, sorry, 1 minus
and minus 2.
0.35, and you said, okay, so, and you've done it for all of them. So what you missed
Yeah.
out is in that first step, you should also multiply it by the probability. You should multiply it by that. And then the
Okay.
second step, you should have multiplied it by the 0.2. Okay, and I think that is, so you you did it correctly. So what I would do if I was doing this in like you did with a calculator, I would just do this for me. And I think that might assist you also. So I would rewrite it as x. I would rewrite it as px. Okay, so we know that the total of ex was 2,35. So how I would write it so that it's easier for you is I write it in a table. So I would then just say 0 minus 2.35, and you can use the calculator and say times 0.1, and your answer you write in there, and you do the same for the second one. So then it is 1 minus 2,35 times 0.2, just remember 2 there as well, and write your answer there. So then if you add all of those answers, you will actually also get to the 1,83. So you just, at the moment, you just did all of that and added them. So you just need to add with each of our calculations the probability. And you will also get the same answer. So rather write it down for you in a table so that it's easier to manage. Hope that helps, because you did exactly the right thing. You just forgot to add the probability to it.
Thanks. Okay, thanks.
Cool. Okay, so back to this question. They don't tell us directly it's binomial, but here they say can either turn out or not turn out, so it only has two outcomes. Binomial is about two outcomes. Something happens or something does not happen. Binomial only two outcomes. Okay, so when we look at this thing, this formula, and I'm like, whew, okay. So let's go to binomial, and that was chapter 5. Let's go to, want to get to, so it was, yeah, I just want to get to that formula. Because it, that formula sometimes might even be right. So let's look at the binomial formula. That's mean that is, if it's not in here, I will get it somewhere else. You want to go through your study guide. Oh, I have it in my other presentations. So let's add it, especially for that first one. Okay. Probability. So let's look at what they give us, and let's see if we can, because I normally want to say something like that is wrong, but but let's check what they give us before we. Okay, 91% right. There's a 20% Turner or sample and 13 motors. Okay, N is 20. Okay, that's correct. X is 13. Correct. We sit with 20 minus 13. Formula. I'll keep that formula in for you as well, so don't worry. Okay, correct. Sometimes you will see that, and that might have been by only asking for that first part of that formula as well. So that might have been in one of the previous assignments as well. Sometimes they just ask you for that first part. But let's see, what was the probability? Was 0.1. X is 13. And so that is still correct. Then 1 minus 0.91. That part's still correct. 13. Correct. Okay, so number 1 is correct. What are we looking for? I said related to a random sample. This is interesting. So is that in a random sample of 20, what's the probability? First 13 turn out. Let's just see why. Bit confused with this question, so let's just go to the tables. There's 91, we've got 20. Yeah, so yeah, let's just do another paste. Making it a bit bigger. I'll just that it's part of a set and keep it in there and it as well for later reference. Let's work on it. Okay, so what's the probability that at most 13? So at most 13, let's just see again, at most means smaller or equal 13. Okay, so let's draw on this. We're looking at 91, 91. Okay, that's not what I wanted. 91. Remember from this table, 91 is at the bottom. So we use this side that I've marked now. So we need to go up to 13. And if we used the top layer of probabilities, we would have used from the top to the bottom. We're sitting at 91, so we're using from the bottom up. At most, let's just see again, at most was, there was a thingy. Most, so small or equal to 13. So let's just, where is that now? It is also very slow. To 13. Okay, 91. That is the three that we needed to do. To add those two together, it is 0,001, which gives us that answer. Okay, so I am opening up the floor. Why is that one wrong?
That's just the probability function, right, John?
Okay,
Oh,
so
yes. Okay, but because we're going bottom up, then maybe, yeah.
okay, so you have it right in the sense because okay, so let's also just see. So you've got it spot on in those things that because we're going bottom up. So if we, that answer you will see is exactly the same as that. Because it's working out that part. So if we were working out with any of those top ones, and we substituted that formula, you would have gotten the right answer. But because we're working from bottom up, the right answer would have been 1 minus that whole thing. And then we would have gotten option 5. So it is because we're working bottom up, and we then looking for that small area bottom up. If we were looking for that, which was that part, we would have had 2 answers that are correct. That one and that one. So in a normal situation, because normally we get those probabilities of less than 0.5. So if you go back to all your previous the assignments and other things, normally we will get something of a 0.2 or 0.25. Then we would use the top one, and then that formula would have been spot on. But because we're working with the bottom one, we actually using the invert every time. So to get to those 3 was very easy from a table point of view, but it was because, remember, we're working bottom up.
Okay, John.
So cool. So that is perfect.
Sorry, John, if I can quickly ask the sort of like a rule or a guideline here. Whenever we were using the top values, so there were previous questions where like 35% was asked, for example.
Yes.
So that'll be comma 35, and then you would start, you would look at the top, so comma 35 is sitting at the top, and then whether it's at least or at most, you'd start from the left-hand side going top down. And depending on whether it's at least 10 or at least 13, whatever the question is, you would then add up those values. But
Yes.
if it's a value sitting on the bottom, then we go to the right-hand side on the bottom and we go bottom up and add those values. Is that
Perfect.
okay? Cool. Thank you very much. Thank you.
Perfect. So
Okay.
if it was 0.05, let's get that. And they ask us small or equal to 3. So let's just say small or equal to 3. We would have gone to 3, and we would have added those. So
Thanks.
yeah. So now I think that's why I'm glad I included the 20, because in the, if you look at, and because it's like a very difficult table to work with if you in the textbook as well. So that's why you would see I want to make it as easy for myself when I work these things out. So even if you can, I'll see, let's, in the recording, you guys would now have, so let me just do this. So if you don't worry, let's undo. I have included it in there for you. So, but it's just a prettier way, prettier slide, but it's easier to work with, because if I need to work with this and it's online, it's not printed, I get very confused. But that's why the same with these ones. If you can, I'll see if I can get a version for you that it's like the like the Poisson, that you can actually read without nearly skewing your head every time. Um, so I'll see if I can do something for you that we just put it in a nice format that whatever way you need to, that you can actually read it like a normal human being and not needing to skew your head, because from this now to suddenly work out what is the bottom side and what's the top side, it's very difficult. Um, so I'll see what I can get you guys so that it's just easier to read. Okay, so the next one is quite interesting. So it's always for me, it's when you and I think that's how the stats have programmed us with that. You're looking for values. Um, so it's easy to pick up values that it's also written in numbers. Um, so just to make the life more difficult for you, now you see there is there's actually a number, but it's 5. Then suddenly they throw in 4. So very difficult, nearly, or I find it very difficult to pick up the numbers if it's in words. Um, so just be again in the exam on the lookout for those things, because very easily one don't see it because one is not programmed to look for it. Um, so let's look at what they give us, and if I need to maybe include a slide with that as well. In addition to learners' absence, is interested in addressing shortage of teachers in rural schools. Previous studies have suggested that 1 in every 4 have school shortages. Okay, so that already. So what is your your probability that we're looking at? What
1
is
divided by
one?
4, 25.
Say again.
1 divided by 4, so 25.
1 divided by 4. Okay, 1 divided by 4. And then you need to put it in decimal, because there's no table that has 1 divided by 4. So again, for me, nearly a question that in the end, it's probably going to look very simple, but it it's these kind of things that that makes it difficult. Um, suppose 10. So again, now I would have probably not even have spotted that. So we know n is 10. Factored each, which one of the following statement is incorrect? Okay, so at least we have now what the probability. We have the n. So if we need to use this one, where is now the 10 is there. So again, look how difficult it is to read that from a table. So let's see if I can see. I'll do a few weird things just to make it easier, and we can keep it in for you guys as well. That, let's get to 10. Maybe we should pick it together. Okay, cool. That at least makes it a bit easier to work with. Okay. So let's see. In this now they give us a few. You'll see some definition questions, some other things in between. So in a binomial experiment, each trial is independent of each other. Okay, that is correct. That's purely the definition of a binomial distribution. The probability that 5 of the 10 schools have a shortage. Probability that 5 out of the 10. So exactly 5. We're not we're not asking 5 or more, 5 or less than 5, more than 5, exactly 5. So let's go to here's 10. I've added with 5. We know we're working with that, so ruler that's supposed to be straight. 0,0584. Let's see. 0,0584. Correct. Okay, so again, I'll keep this for you so that, and let's just also duplicate it that you can actually have a set of that for the exam as well, then you have the easier table to look at in the exam. Okay. Then the expected value of a number of schools with shortage of teachers is 4. Okay, sure. Expected value. Can anyone remember what that formula is? This is a curveball that we haven't seen in this set of questions. It's actually a very easy formula, so the expected value for your binomial distribution is that. This is quite this for me was a curveball because you're not really not thinking about that. So n is 10. Your pi is 0,25. So those two multiplied together, 10 times 0.25. Oh, okay. 2.5. Not 4, so that is the incorrect one. Let's just look at the other two. Probability of school having shortage of teachers is 0,25. That is what we calculated there. So if that is the shortage, the non-shortage is 1 minus 0,25, which is 0,75. Which is correct. Then the probability that 4 of the 10, probability exactly equal to 4. So let's look at the table. 4 is just the one on top of that. 1,0460. 1,01460. Correct. Okay, so C was the incorrect one. What, and just again a tip, I think that is, then before I get to your question, just a tip. They can, and I have seen it in a previous exam paper, that they can give you this where they say previous studies have suggested that 1 in every 4 rural schools have a shortage of teachers. Then a question like this can come up where they say, what is the probability that 4 of the 10 schools does not have a shortage of teachers? So they can ask you then the opposite. Then you would need to go to the 0.75 scale, which is just at the bottom of it. But when you work up again, and then 4 would have been that number and not that number. So I have seen it in a previous exam that they basically ask you then does not have a shortage, and when you sit with the opposite. So then you need to think, okay, does not, I've asked it in that one, it is 0.75. Then you need to remember, okay, does not, I need to work with a 0.75. 4 over 0.75 is actually that number. So just as a tip, be very careful just when you read these things. It happened once before. It might not happen again, but just be wary. Lynn, you had a question, and then Simon, you can also.
Oh, thanks, John. I won't be long. So in binomial, the expected value does not mean the mean. What does it?
It gives the mean.
It is the mean again. Okay. All right. Cool.
Okay, so with expected value, the discrete, binomial, and Poisson have 3 different ways of working out the expected value. So they have 3 different ways of working out the mean. And I think that is the important thing nearly is, and I'll share my summary PDFs as well again. I've written it down so that you know that the same with the variance. If it was the variance of a binomial is that calculation. Okay, so again, discrete binomial Poisson have 3 different calculations for discrete for mean and variance. So just be careful, but I will share that summary with you guys as well again, so that you just have it. Okay,
Okay, cool. Thank you.
Simon, you had a question, or are you happy?
No, I'm happy, John. Thank you.
Okay, cool. Okay, so next one. So here is just also for you guys, but you don't need to struggle with this table. So that there is just one that is a bit nicer that you can work with. Because I hate it when it is the other way around. Okay. So now let's, very similar. Now Now suppose 8 rural schools are selected, independent of each other, to check whether or not each school has shortage of teachers. Similar to the previous question, studies have suggested that 1 in 4. Okay, so we go back to 1 in 4. I don't know why now they do this. That's fine. We don't have n is equal to 8. We create n is equal to 8 for you, so let's just that. You have at least another one that we can work with. And you can use. Okay, so the probability that, okay, so now I can understand why they ask it, that at most, so now they're including those things, at most, let's see, at most, smaller or equal. So what's the probability that at most 1 of the 8 schools have a shortage of teachers? Okay, still 0.25. We're working with 8, working with 0.25. At most, so we said 1 and less. So that is 0.3671 or something like that. 0.3671. Correct. Okay. So please use this small table that is added here, because it really helps a lot. Variance. Okay, so there we get to the variance. We've now seen the variance. I quickly said what it was in the previous one, even though we didn't need to do it. N is 8, so just now, please, one is, because we talk about the previous question and things like that, just be very careful that you don't use 10 now suddenly in this question, just because 10 was used in the previous question. So 8 times 0.25 times 0.75 is equal to 1,5. So that is correct. So just remember that it is 8 now that we're dealing with. The probability that at least 0, what's the probability that x is bigger or equal to 0? Hey, you guys tell me.
Could be everything 0 and more, right till the end of the column, I guess.
Okay. So it would be all of that. And how much will that be?
No, it's okay. I don't know.
1.
Yeah, okay.
Okay, so you nearly wanted to start adding all of them together, Lynn. And I think that is what you guys also need to remember. So when we did discrete, where was the discrete? All of those probabilities added Okay, all of those probabilities added to 1. Now that we are busy, now that we're busy here, if you add all of that together, you will get 1. So here in 25, you add all of those together, you will actually get 1. So all those probabilities will always add to 1. So bigger or equal to 0 will be 1, so it's definitely not 0, and that's the incorrect one. So here nearly is probably the opposite now. So what's the probability that at most we said smaller or equal to 8, so that is everyone. It is 1. Okay. The probability that at least 1, sure, at least. See, you can see I'm also at least bigger or equal to probability that at least 1 of 8 schools at least bigger or equal to 1. Okay, so now again you can do two things. You can add all of those together to get your answer, or you can say, well, I'm actually just been looking for that number. So 1 minus 0,1001 will be the same as if you have added all of those numbers. Which will give you hopefully 0,899, and let's hope that okay, so that is correct. So again, like we did, and we're going to show later on, in any case with the normal distributions, easier for me than adding all of those together. Just subtract that one that is not included. Okay, so that is hopefully Poisson. Oh, here's another one. Ah, sorry, binomial. So done with binomial, go into Poisson. This was, yes, Lynn.
Sorry, Shan, I won't be long. For all the tables, the binomial and the Poisson, the sum of probabilities in each column is always 1. Is it across all tables?
All tables.
Okay, awesome.
All
Good.
tables. So let's,
Good.
all of these, so even there, that will always add to 1 from a binomial. Poisson, the same. That will add to 1. Okay, so exactly the same with Poisson will add to 1. When we get to the, I don't think the normal distribution is also on this group of. So when we get to normal distribution, I'll show you some trick there as well about the tables. But let's first now keep with Poisson for today. I'll show you another trick next time. So just by that, I see, let's quickly see. Today's for 8:15, so we will have a 2-hour session next week again. And then that leaves us with about 12 days. So whatever is not done next week, I'll schedule for us sessions in the week. It will not be 2-hour sessions, but then from at 17 nearly, I will schedule us 5 or 6 o'clock or 7 o'clock at night. I'll just check what my schedule looks like. I will schedule us our sessions so that we can complete it by the 22nd. So that nearly the 22nd we should be done, and that it's more uh, around robin kind of questions. You throw questions to me and we answer things, but it's not a formal session, but it can also be a formal one where you have posted questions on WhatsApp and we go through it. So we will work towards that we finish as most as possible next week. Okay, so let's go on with Poisson. This is again one of those that wherever I've nearly told you guys, when we do binomial, when we do Poisson, use the tables. So they like to throw in these kind of things. And let's just get a clearer Poisson formula. That this just feels a bit clearer than the one that is on here. Hope it's a bit better. So okay. So that is what we looking at. So let's complete it and see then which answer is correct. Suppose that the number of grade 8 absences are Poisson distributed with a mean of 3. Okay, so let's already in there substitute what we can for that. Okay, so that seems right. That can just be because of what we are dividing with. Okay, so all of those ones seems correct with the e minus 3. So nothing that we can cancel out yet. Use the formula to calculate the probability that 2 learners are absent on a random. So x is 2. Okay, so what does that mean? That means basically 2 factorial, which is 2 times 1. So if we had, and this is just so that sometimes they don't mention it in the books, 10 factorial is 10 times 9 times 8 times, when it goes 6, 7, everything, 4, 3, 2, and 1. So sometimes you don't go into that detail in the book. So 10 factorial means that we basically times that out 10 times 9 times and whatever we get. So 2 times 1 is actually 2. Okay, so again, nothing that we can get out of that, but let's then see. 3 to the power of 2 is 9. 3, 2, 9, not 3, divided by 2. 9 divided by 2, 4.5. E minus 3 stays the same. 5. That is the correct answer. So what obviously this student that sent it to me this last year, what he or she did was to say 2 and 2 cancels out and we left with 3, but obviously can't do it that way. It's 3 to the power of 2, so it's 3 times 3. So 9 divided by 2 is 4.5. That gives us C. So again, it is nearly, let's format that picture. You can use it, you can, okay, why is it only one side? To do on both sides, don't worry then. So that you have this. Cool. So there you, again, formula that is available. Yes, it is in your study guide, but then you don't need to go and search, because if you now look where I found it and now suddenly you need to search for that in the exam, it takes time. So again, here it is, use it. What will also happen is you won't get in the exam where was that one? You won't in the exam get that and the Poisson. You won't get both of them in a formula format. It will just not happen. Okay, so in the exam you will get a discrete, you get a binomial, you get a Poisson. That will be part of your first part of the exam. The first paper covers study unit 1 to 5. You will get one of each. It might be that for Poisson or this or binomial, you need to explain a bit about the, the function, but it will not be both, and sometimes not even at all. I like rather to use the formula pages for that. Okay, so let's go again to the next one. Suppose the number of voters entering the voting station in the UK per minute. Okay, so that already per minute is the difference between binomial and Poisson. Binomial could have said the number of people entering is plus entering or no entering. But when you add a time to it, it is Poisson distributed. Okay, they tell us the mean is 2.5. So we know lambda is 2.5. Okay. Automatically, let's go to get to the table of 2.5. Just makes it easier. And you can see we previous stage we did. Obviously, I can't unclear the colors, so that might even be some of the answers. Let's just let's copy all of that we can see numbering to it as well. Edit. I'll move it around so that we can just see what we are looking at. Okay, so they ask us the probability that exactly 4 voters, okay, x4 2.5 exactly 0,1336 wrong. Okay, unfortunately we're looking for the correct one, so that is not the answer we're looking for. The probability that no one will enter the voting station. Okay, so no one is x equal to 0. X equal to 0. So remember that it's not 0 unless it says 0 in the table. So there's still a probability connected to that 0, which is 0,0821, not 0, not the correct one. If X is the number of voters entering a voting station, we've said it, the variance is 2.5. Okay, so what do we know about Poisson distribution? The mean equal to 2.5. What is the variance?
Same, 2.5, I guess.
Okay, so the variance, and again, it's one of those things that is unique to Poisson, also 2.5. Okay, so just be very careful again for this is part of nearly the definition set that is crept in here. So that is correct. We're looking for the correct one, so that is the correct answer. Okay. Let's look at the other two, just for clarity as well. Okay, entering voting station, given that what's the probability smaller than 1, bigger or equal to 0? Smaller than 1, so it does not include 1, bigger or equal to 0. It's actually again just 0. So that question and that question again is referring to exactly the same thing that you needed to calculate. But just again, just realize that there's a few ways that they can ask you to get to the same answer. But this one, be very careful. So they said smaller than 1, so it does not include 1. Okay, what is x entering given that x is smaller or equal to 1? Now we go smaller or equal to 1, but not including 0. It's actually just 1, which is 0,2052. So that's why that is also wrong. So that for that one, they could have asked you also, what's the probability that x is equal to 2? What? 2, 1. They could have asked you that as what's the probability that x is smaller than 2, bigger or equal to 1. So that and that, those three are exactly the same kind of question, just in three different ways that it can be written. So with these ones, just be very careful when you look at the question set. Um, and it might be, and we've seen with stats, it might be that they have in one question that as option one, that as option two, that as option three, all of them the same, and you like, eyeball, but this can't be. They tricking me here or something like that. So just be very careful that when you're reading the things, and again, that's why we know UNISA is all moving online in any case, but that's why I dislike in a sense for online exams, because it's much easier if you have this in front of you, paper, and you can eliminate things when writing. It's very difficult to do it online. So it's very easy if you had this on you, in front of you, to nearly work it out. Okay, we've got another 13 minutes, so let's see if we can at least get all the Poisson questions done. Suppose now we have knowledge that the number of grade 10, so again, it's probably one of the previous questions, at one of the schools of Poisson distribution with a mean of 4.2, what is the probability that at most 10? So let's go 4.2, probably highlight it again. um, at one. Okay, at most. So let's see. At most, at most, at most, at most. Oh, that's at least. At most. So what's the probability small or equal to 10? Okay, so now you guys can see I already highlighted this. So you've got two options. Add all of these together and you get your answer. Or say 1 minus and add all of these together and you will get the same answer. So those two should be the same answer. So I'm a bit lazy again when it comes to this stuff. I would have added those two together, or those 3 or 4, instead of all the 10. I get something like 0,004. If I add those together, so then 1 minus that must give me 0,996, which is option B. Okay, so you can check if you add all of those together, it should give you the same answer. My shortcut is I rather say 1 minus, because like I said previously, Lynn, all of these add to 1. So you can do nearly the invert as well. And again, it's preference. So if it was sitting here in the middle, 7 or 8, I'm like, it doesn't really gonna matter. I in any case would need to add 7 numbers or 8 numbers here, I would have needed to add 7 or 8. It's a preference for you. So whatever you prefer, whatever you were most comfortable with, do it that way. If it was probability of x smaller or equal to 2, then it's something different. Then it's those three, and I would just add those three. So again, please let the question really guide you in how you approach it, and what you need to work out. Okay, next one. Let's see. Okay, so we're actually going into normal distribution now. I just want to check if there is else. So before we get into that, questions up until now. So this is up until study unit 5. So what we've done now covers your first part of your exam. First part of the exam, 12 or 13 questions. You've got an hour. They give you normally 15 minutes extra. So let's say you've got 75 minutes to do those 12 or 13 questions. So when the mock exam is available, and I don't know if that is also in the papers that was shared yesterday, but please share those papers with me as well. When the mock exam is available, use it as, and I think it will be a mock exam you can write once or twice or 3 times even. I'll ask the lecturer to also have it open for you for a few attempts, so that you can just see how quickly the time goes, and how you need to position yourself in that. Yes, Lynn.
I was actually going to ask, will we get multiple attempts for that same mock exam? It's good to be in that situation a couple of times, you know, and the questions will be
Yes.
static. Yeah, okay.
So I will ask the lecturer to basically make it available for you for multiple attempts, so that you can get used to it. I think there was a question around multiple attempts on the exam. There, so let's put it this way: when you have issues during the exam, so when the system bombs out or things like that, the your answers is captured. So don't worry about that. Your answers is captured as you go along, because it is, when you're done with question 2, you move over to question or 3. Question 2 you can't go back to. So, but when it totally bombs out, you will be able to connect again. So it's not that now your exam is over and tough luck. And that is where they say you get a second attempt, because then you can rejoin. You will or restart a paper, or you will then join wherever you stopped with the previous paper. Um, so please don't. If something happens, also um, WhatsApp me during your exam. I'll I'll forward all those WhatsApp to the lecturer in any case, um, because he's at hand. All the tutors are at hand at that stage. So please, it's not when you're in that exam situation, you by your own. The channel is open to myself and the lecturer. Um, the group, the WhatsApp group will be closed for that session, Jess. Um, but I will be available because it is sometimes you struggle to log in or there's something happening. Um, what also happens is, and I will just make sure, is your exam is, it's supposed to be 1 hour for the first session, 1 hour for the second session. The lecture is giving 15 minutes extra for log on and those kind of things, but it's actually an extra 15 minutes for you to do the problems. What they're also doing is they stretch it. So they say you can write between 8 and 12 or 8 and 1. So that not everybody needs to go onto the system at 8 o'clock. Just give you enough time to be finished by 1. So please don't start at 12 and think you can squeeze in 25 questions in an hour. Sometimes what happens during the process is that the lecturer will say, okay, but let's extend it by an hour because of things that happening. So also check, there is a timer on, and I think that will be in the mock exam, but it was in the assignments as well. There is a timer on while you're writing, and sometimes that timer um, is extended. So just keep your eye on that timer as well, because sometimes they add an extra 10 minutes for you because of something that they know has happened. So just be all the time watching that timer if something changes. Um, and also another tip is, so if you know there's 13 questions, you've got 5 minutes, you're only at question 8. Don't don't just stop and think, okay, now it's done. Guess the next 2 or 3. It's fine. It's 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 they're gonna mark it. You have it, it's right or wrong, but don't, then I would nearly use some of my my how I cancel things out and guess between 2 or 3 things. So just nearly get into that process as well, that it might be normally as the first part of a questionnaire is fine because that's the things we covered up until now. The second session is normally the more difficult because there's lots of calculations. Um, so that's why for the next part of the paper, we're gonna really look at, so here is Poisson things in here, but we're really gonna look at how to make it easier for you to use Excel so that and your calculators, just to make that second part of the paper quicker and easier to do. Okay, so that's it for today. We've done a 2-hour stretch. We'll do another one next week, Saturday. What we don't finish next week, Saturday, we will do sessions within the week so that really we I want to be finished by the 22nd. That the 22nd is nearly shows some other exam examples or things that you have picked up while you're preparing. So please send those WhatsApps and things to the group. We include it, we look at it. I am busy now